going to talk about acid-base indicators. We did this a little bit in Chem 20, so this is kind of a review for you guys. Indicators are a mixture of a weak acid and its conjugate base dissolved in water. The acid form of the indicator is written as HIN. So in this indicator here, I got some right here. This indicator right here, there is acid and base. It's in an equilibrium system. This indicator is right now. It's got acid and base right now. It looks pretty bluish, does it not? Here, let me. So you can see it's kind of a blue, right? I mean, it looks like that. It's actually kind of a greenish color, probably. It's just really concentrated in here, so it looks maybe a little bit more blue than it is. It's not the best bottle to have it in. It's kind of tough to see. And like I said, there's so much of it there that it kind of looks bluish. It's probably got a little bit of both colors blue, and there's a little bit of yellow in there as well. It's just really hard to see that, okay? This has both acid and base. It's in an equilibrium system. If we wrote this out, I'll show you what the equation is going to look like for this, okay? Now, you might say, what is that acid, what is that base? And the answer to that is, well, in this case, it's bromothionyl blue. What does that look like? The acid is incredibly complex. So is the base. It's got phenyl rings, it's got benzene rings, it's got this and that. It's like the compound is about this long, okay? If you wrote it out. And on your pages, it would be this long, all right? So it's incredibly complex, and that's not the point of this, all right? You don't have to know that. But basically, with every indicator, it's got an acid side to it and a base side to it, and it looks something like this here. And this is how we would write this, basically like this here. So we have our acid here, right, our HIN, acid here, and our base is here. Acids produce hydronium. The base would produce the basically the water, in this case, the base of the acid there. Now, that's what it always looks like, all right? What we're going to talk about is how indicators work here. Indicator color changes are explained by Le Chatelier's principle, as always, all right? Bromothionyl blue, this is what it looks like. Bromothionyl blue, right here, this acid, is yellow when it's an acid, and blue when it favors the base part of this reaction, okay? And that's basically what this one would look like. And once again, we just write H. This would be the acid part of the bromothionyl blue. This would be the base part with the negative ion, bromothionyl blue base part, okay? So that's your acid, that's your base basically. In between these two, of course, is what color? Green, okay? So we're going to talk about that in a second here. When bromothionyl blue is dropped into acid, it increases the H3O plus concentration, okay? Now, the reverse reaction is favored. Bromothionyl blue changes to a yellow. Now look here, guys. Go back to here for a second. This is kind of tough to show you, and it's kind of tough to wrap your head around it. So here's what I'm going to say. This is the equilibrium we are talking about right here, this one, okay? Now, if I put acid into here, now I'd have to use a lot of this, so that's why I'm going to do kind of the opposite here, all right? This is the one I'm interested in, this one right here, okay? What this has in it is HBB, right, with water to give me BB minus and H3O plus. If I put acid into here, into this equilibrium system, it spikes up the H3O plus in that equilibrium system. Look right here. If I add HCl to this system here, it's going to increase the concentration of that, correct? Okay? So if I put acid into here, this would turn yellow. All right? Because what happens is this spikes up, and if I got more H3O plus, what happens? I try to use it up, right? So I try to use this up, and I try to use that up, and it turns into reverse reaction favored, yes? We've talked about that before, okay? So it favors the reverse reaction. This would turn yellow, all right? If I add acid into here. Now, we don't do that, though, because this is my indicator. So look, I'd have to add, and it takes a long time to make this stuff. So what I'm going to do is the opposite. I'm going to add acid to this, but I'm actually going to put this into the acid. Okay, same thing, yes? I'm going to put it into an acid, and it's going to show you that it turns yellow color. So these drops of bromothymol blue are going to turn yellow when I put it into the acid. Not the acid's not turning yellow. This indicator is turning yellow. Okay? Yes? Okay. So once again, this is my acid here. Okay, as you can see, it's clear. When I add the acid to this indicator, okay, but I'm going to do a little bit backwards here. It's going to make a yellow color. I'll add a little bit more. Okay, so there you go. Okay, so the indicator has changed to yellow, not the acid. The indicator has changed to yellow because I've spiked up the hydronium ion concentration in the indicator, all right, by adding this acid to the indicator. All right? Yes? Yeah. I'll show you right away. Just wait. Okay? So, be patient here. All right? So, you can see that when I add in a bunch of H3O plus to this indicator, I already had the H3O plus in the test tube there, but I add this indicator in, it spikes up this H3O plus concentration in the indicator, and it shoves it this way and it makes it yellow color. Okay? Now, so bromothymol blue is dropped into acid. I'm basically adding the acid to the indicator, really, is what's happening. It increases the H3O plus, reverse reactions favored, it changes to a yellow color. That's what's happening with indicators. When you drop it into a base, okay? When I drop it into a base, the indicator experiences an increase in hydroxide, okay? When I add it to a base. So when I add hydroxide into here, well, this is where it gets a little confusing. Remember, water is made up of H plus and OH minus, right? So the more OH minus I have, the less H plus I have, yes? And vice versa. The more H plus I have, the less OH minus I have. We did the H plus version already. I added the H3O plus. I increased the H plus concentration. The OH minus concentration went down. Now I'm going to do the opposite. I'm going to put it into a base, which has a lot of hydroxide, which means I have less H3O plus. So I spike up the hydroxide, and I drop down the concentration of H3O plus. So if I go back to this equation here, what I'm now doing is I'm taking this out of the system, okay, and I'm adding up the hydroxide, but I'm decreasing the H3O plus, all right? If I take that out, the indicator is going to want to go that way, right? I got to make more of that to get it back to equilibrium. So the products are going to be favored. It's going to turn a blue color. So once again, here we go. Here's my base here, okay? Here's my indicator. I'm going to add the base, the hydroxide, to the indicator, right? Okay? Except for I can't get it into here, so I'm just going to do the opposite. It's going to spike up the hydroxide concentration in this, which means it depletes the H3O plus concentration, takes it down, and which of course favors that way. There you go. Okay? So you can see the indicator, okay, is going this way now. Okay? The indicator, because I added all that hydroxide to that indicator, those drops of indicator there, the hydroxide shoves it this way because I really taken out the H3O plus, right? They're combined together, right? The higher the H3O plus, the less hydroxide I have. The more hydroxide, the less H3O plus I have. So I have lots of hydroxide in here, which means this goes down, shoves it that way. Blue, very blue, pretty blue, yes? All right, let's, oh yeah, okay. Now this was blue, you might say, hey, that was blue already. Yeah, but you know what? You have to remember, this is very, very concentrated. That's all that's in here. Okay, yeah, there's some water in there and stuff like that, yeah. But it's hard to see because there's so much of it. I only used 3 drops, so does it look lighter? Sure it does. Is it lighter? Probably not. Okay, it's probably darker. But it doesn't look like that because I got so much in here, and of course, I added it to quite a bit of water here, all right? And of course, you know, just to prove the point here, what about bromothymol blue when it's, you know, when the H3O plus and the OH minus are kind of the same? What happens when it's kind of neutral? In other words, water here. Now I hope this works, but we'll see. Okay. It obviously should be a nice, pretty green color. Okay, which obviously is the combination between blue and yellow. Yes, that's, who said aqua? I'll punch you. Some guy said it. Oh, that's it. Okay, so you can see, okay, 3 different stages here, basically, of that, right? We have our, I guess I should hold it this way. We have our acid, we have our neutral, and our base, right? Acid, neutral, base. So you can see that that's in fact the case. Now don't forget, we're adding it to, okay, we're increasing the H3O plus concentration of this, we're increasing the OH minus concentration of this. We get confused sometimes. We're talking about the acid and the base that was in there. I don't care about that. I'm talking about this equilibrium system here, this indicator system here. When I add H plus to it, it forces it one way. When I add OH minus to it, it decreases that, it forces it the other way. Okay, that's what we need to talk about, and that's what we're talking about there with indicators. All right? Next, what do we got here? So, when bromothymol blue, that's the acid one. Let's see here, the base, okay. Hydroxide concentration increases, H3O plus. Forwards reactions favored, it changes to a blue, okay. Each indicator has a particular pH range, in which form the indicator predominates. So, we know that, for example, once again here, we did this in Chem 20, and you get your data booklets out, guys, data booklets. The page after the acid bases. Turn to the page after the acid base table that we've been talking about. Okay, so a pH less than 6.0 will be yellow, of course, with bromothymol blue. A pH greater than 7.6 would be blue, and in between, of course, is a green color. And we can talk about that. And if you remember in Chem 20, we went to the lab and we talked about these things in the lab, and we did the spot plates. Remember, if you're in my class, that's what we do. We go to the lab, we do the spot plates, yes, remember? And then you take the indicators. There's alizarin yellow, R, there's indigo carmine. You remember all this phenol red? There's a whole tray of them, and you dump in 2 drops, and you see what color they are. And the guys were like, it's red. And then the girls were like, no, it's fuchsia. Aquamarine. Right? Sunflower yellow. What? Seriously? It's yellow, red, blue, green. Pick a color. Hey? You guys start making up colors like mauve all of a sudden. What's that? Hey? Chartreuse. Oh, don't even start with the chartreuse. Hey? Just pick a color. Pick a color. Anyway. All right, here we go. The point is, we did that, remember? And I said, make sure you guys have a girl in your group, because they'll tell you actually what color it is. Guys will be like, oh, blue. And then the girl will be like, aquamarine. Or whatever. I don't know, whatever. Okay. Anyway, so we remember that? Yes? With the little spot plates, the little white plates, and you have like 9 holes, and you put stuff in, drops, and you, yeah? We did that. That's what this is. Okay, same thing. So here we go. Thymolphthalein, if it's colorless, let's look that up. Thymolphthalein, find it on your sheet there, guys. If it's colorless, what kind of pH do we have? 9.4 to below, right? Below 9.4 is somewhere. I don't know what it is exactly, but it's below 9.4. Quit talking. Here we go. Bromocrystal green is, it says here it's a blue. It says 5.4 and above, right? Means it has to be higher than 5.4. That's all I know, right? We're going to write all these down. We're going to narrow down the pH range. What is that? Crescel red? Crescel red. Crescel red has 2 pH ranges. So some of these indicators actually do 2 different pH ranges. This one here says that it's yellow. So I know that it's got to be 1.0 and above. But it also says for the other one it's 7.0 and below. So that's kind of a unique one there. Not all of them do that, but I know that it's probably between 1.0 and 7.0 because it's yellow no matter what. I don't know which indicator we're talking about here, which one we're using, but it's somewhere in between there. Okay. Phenolphthalein is a colorless one. So that, if you go down to there, is 8.2 and below. Yes? And bromomethyl blue was yellow, and we just did that one. So where's that here? Bromomethyl blue, yellow. That's 6.0 and below. So what's the narrowest pH range that you can come up with from those there? I'd say probably somewhere from what? Yeah, 5.4 and above, yes. So I'd put 5.4 probably to 6.0, yes? Once again, you can double check here. Is 5.4 to 6.0, it's somewhere in there. Let's pretend it's 5.5. Is 9.4 and below, does that confirm 5.5? Yep. 5.4 and above? Yep. Is it between 1 and 7? Yep. Is it below 8.2? Yep. Is it below 6.0? Yep. So that's the narrowest pH range we can get. Okay? All right. Then we get to questions like this. This is exactly what we just finished doing, guys, on your quiz. We're running out of time here, so I'm just going to do these for you, I think, today. We got 0.10 molar H2S. We need to calculate the pH and predict the color. So H2S. And I'm going to do this quickly here. This is how much time it needs to take for you, too. H3O plus, because it's an acid, and HS minus conjugate base. All right? It was 0.10 molar, is that correct? This will be X, this will be X. Okay? I'm going to look up the Ka value for H2S, which is, oh, come on, quickly, quickly. Hydrosulfuric acid, where is it here? Come on. Come on. 8.9 times 10 to the minus 8 equals X squared over 0.10. X equals, calculator, we'll multiply those two numbers first, then we'll take the square root. And I get 9.43 times 10 to the negative 5. I will take the negative log of that. 4.03. Final answer for pH. Done. Okay. That's as quick as you need to be. And we're going to look it up now. It said with what? Methyl orange, I think I said? Methyl orange. So let's look up methyl orange. Methyl orange does. Went the wrong way with the page there. Here we go, quickly, quickly. Methyl orange does 3.2 to 4.4. And it goes from a red to a yellow. And this is 4.3, so what color is it going to be? Orange is the correct answer. Tangerine? Seriously? Citrus. Oh, citrus you. All right, here we go. Orange, right? Because it's in between that pH range of 3.2 to 4.4, 4.0. So probably somewhere in the orange range. Next one. Here we go. NaOCl. Now this is kind of predicting a little bit of stuff which we're going to do tomorrow. NaOCl minus, or NaOCl is made up, of course, when I put that into water, NaOCl gives me Na plus and OCl minus ions, and of course OCl minus ions are a base. All right, and we're going to talk about this a little bit more tomorrow. So OCl minus, hypochlorite, is a base reacted with water. Once again, gives me HOCl, conjugate acid, and of course hydroxide. And I think once again I got a 0.10 molar here, is that correct? Okay, X. Now, I need to use the Kb value because we're talking about a base here. So, to get the Kb value, we need to do, of course, Kb equals 1 times 10 to the negative 14 over the Ka value of HOCl. So HOCl, hypochlorite, let's see. Now, sure, I won't be able to find this one either. 4.0 times 10 to the negative 8. Yes? Okay. So let's divide those two, which I'm sure somebody's already got that, but that's okay. 4 times 10 to the negative 8. And I get 2.5 times 10 to the negative 7. Like so is the Kb value. I'm going to use that with, of course, my equilibrium here. x squared over 0.10. So I'm going to multiply those two numbers first. Take the square root, and I get 1.58 times 10 to the negative 4, which is, of course, 1.58 times 10 to the negative 4 right there. That's my concentration. Yes. I'm going to take negative log. I get 3.80 is the pOH. Because remember, we found negative log of hydroxide. So my pH is 10.20. Final answer, all said and done. 10.20. If I need to predict the color, what indicator are we using there? Alizarin yellow R, yeah. Alizarin yellow R does this. Now, is 10.1 to 12.0, and it goes from a yellow to a red. Now, 10.2 is not really in the middle of those two, right? So, you know, what are you going to see? 10.2 is basically somewhere right there, yeah? 10.2, kind of on that spectrum. So what are you going to see? Probably, you know, are you going to get a question like this? Probably not, okay? They'll make it clear, but probably something like orangey? Yes. Don't say tangerine, I'll punch you. Tangerine, come on. Just wait, I got a worksheet for you. Orange, okay? Probably a little bit more yellowish though, right? Probably because it's closer to that yellow scale. So yellow-orange kind of thing, I would say. So tangerine, yeah, sure. I'll punch myself now. Yellow-orangey kind of thing, all right? All right, here is your worksheet.